The answers, okay, let me zoom out a little bit. Okay, I'm hearing all sorts of noise, so well, hopefully, like I said, we're going to do a lot of review today. Just practice. Hopefully that's going to help. Although I'm sure the waking up at 3 a.m. to do your homework doesn't help.
It did help. But I'm tired.
Okay. Whatever you say. What about the first one?
Did you make n plus 2, n plus 1, and get rid of the n plus 1 beside n plus 3 at the top? Yeah, I mean, like,
Hang on. I'm trying to think of what you're talking about. Which one are you talking about? Say it one more time, but slower.
First one.
Yes.
N plus 1 out of n plus 2. Yeah, I mean,
If I make n plus 2 to be n plus 2 times n plus 1, they're on the same side of the fraction. They're not going to cancel. Do you understand what I'm talking about? Because they have to be, it's a fraction still. They're only going to simplify if it's on the top and the bottom. They don't simplify bottom to bottom. So if I expanded this to say n plus 2, n plus 1, these n plus 1s are not going to go anywhere. It has to be one on the top to one on the bottom. And so what I did is I paired biggest to biggest. So this one was the biggest here. This one was the biggest here. I paired those two up, and I said, okay, of those, this one's smaller, so I'm going to start with n plus 3, and I'm going to work down until I see the n plus 2. Another thing that you could have done on these, if you don't like this method, you could have taken your overall smallest guy, which is n, and expanded all of them until you got down to just an n. I think it's a little bit more work, but here, let me show you what I'm talking about. So the problem that we started off with was, here it is, okay, n factorial, n plus 3 factorial, over n plus 2 factorial, n plus 1. So if you don't like the way that I did it before, that's okay. You can do it this way. If you're having trouble figuring out what to pair, out of all of those, this is the smallest one. So I'm going to write all of them until I get down to an n factorial. So I'm going to say n factorial, n plus 3, n plus 2, n plus 1, n factorial. So it's a lot more writing, but it'll work. N plus 2, n plus 1, n factorial. N plus 1, n factorial. Now, I cannot cancel what I was talking about for you here to here. Those are not going to simplify out. Do you understand why? Okay. So then if I'm doing it this way, I can say this pair cancels, that pair cancels, then I can just go through what's left. Here's an n plus 2. Here's an n plus 1. So it leaves me with the same answer of n plus 3 over n plus 1. I don't like that method as much because it's got a lot more writing involved, but it does come up with the exact same answer that you get from here. Okay? Yes, ma'am.
So I put 21 over 4.
Okay, you've got to remember that the formula for this says if R is my term, it is the power over R minus 1. Okay, and the reason that we do that is because the first term is always, because you know how we're going to have, like, let's say x and negative 3, you're going to have x and negative 3, and in front of each of these is going to be 21 choose something. We start at 0. Because what's that going to do is that's going to say I'm going to have none of these and all of those. Okay? Yeah.
So for number 2,
Uh-huh.
what is the factorial?
Mm-hmm.
Like, how do you find n? Do you use
I wouldn't use the factorial one. Like for this guy up here, I didn't even bother with it. What I did is I said, hey, look, here are, well, that's easy. N goes from 1 to 9. And then if you're doubting whether or not that is 9 factorial, you can just check. And you can say 9 factorial, and it was the same number. Yeah, because I don't know. I know if I see 1, 2, 6, that's usually a factorial pattern. I ain't got no idea what gives me that with factorials. But the tops I get pretty easily. Okay? What's the pattern? +1, or we can just say if I'm starting with the first term, second term, third term, fourth term, all the way up to ninth term. So I can think about this as the sum of the terms from 1 to 9. Understand where those numbers come from so far? Where that number is on top. You okay with that? And then I look to try to figure out what's going on in the bottom. And then that's just 1 factorial, 2 factorial, 3 factorial, 4 factorial. So that's why I did that. Okay? 1, 2, 6 factorial. Alrighty? Okay. Any of the others? Yes, sir.
What was your first step in solving for 1?
One more time?
What was your first step?
For number 1? For number 1, I looked at the guys that it gave me, and I paired up the biggest on the top to the biggest on the bottom. Okay? And then since there was only one pair left, they naturally paired up. And when I looked at the biggest on the top, I said, okay, of those two, this guy's smaller. So I'm going to spread this out until I get to this. Okay? Yeah? Like I said, practicing today, main focus. Homework answers. Oh, that's a heavy sigh. By the way, these are called answers. This is not your work. So, there wasn't supposed to be a burn, but okay. For each of these, I do expect to see where those come from. Because I know your calculator does most of the work for you. Like the numbers. The number part. Yes, sir.
So for numbers 21 through 28, is it enough work just having all of the possibilities listed out? It would be like 4 combinations, 0, 3.
Yes. For for example, for number 21, the work that I would have expected to see, since 21 gives me, ladies, 3x plus 1 to the 4th. The work that I would have expected to see for this is 4 choose nothing, 3x and 1, where 1 is to the 0 power, 3x is to the 4th. And then you would just keep going with that. Okay? And then if you do that, you can skip straight to the answer if you want to. I usually still would say, okay, so that's going to be 1. 3 to the 4th is 81x to the 4th. And that's just 1. And because I like to see those steps for myself. But as long as you've got that, I'm okay. Okay. Anybody else? Questions on any of the other problems? Or what work needs to be shown, or how the heck? Sydney.
So what's the difference between what it was asking on 30 or 29 through 33? It asked
Right. Because some of these problems are asking you for what's called the coefficient. Some of them are asking for the term. Okay? If they're asking, let's do one of the homework problems, which was 29. Let's do 29. So it's asking for the coefficient. I don't know what happened to this paper, but let's skip it. That's just weird. 29 is saying the coefficient of x to the 6th in x plus 3 to the 10th. Okay? I know for every term that I'm going to do with this, it's going to be 10 choose something x to some power, 3 to some power. So far, so good? I want x to be to the 6th power. That's what the coefficient is. I want to know the number that matches up with x to the 6th. If this is 6, this is going to be 4 because these numbers have to add up to 10. And that number always goes on the bottom. So then I would just take my calculator because I really don't feel like figuring that out by myself. E4. So that's 210 times x to the 6th. And 3 to the 4th is 81. Times 81. So I get, and then x to the 6th. And since it's asking for just the coefficient, it's that piece. Now, on problems like number 35, 35 says I want the 5th term in the expansion of x plus 3 to the 7th. Well, when I'm talking about these guys, the way it's always going to go is it's going to have the highest power on x, the next power, 4, 3, 2, 1, and then no x. Okay? If we look at this, 1st, 2nd, 3rd, 4th, 5th term, that's what I want. Okay? And so for that one, it's going to be 7, choose something where I will have x to the 3rd and 3 to a power. So if that's 3, what's this going to be? 4, and that means 4 goes down here as well. Okay? Because you don't want to sit there and expand all of that. That would be horrible. Okay? Go back to the answers. Any more questions on these? Today is practice, practice, practice. There was no 39. Or was there 39? No. No, I can tell you what 39 was. It's just ugly. Yeah, there's a good reason to put a star next to it. That was an ugly problem. But just for curiosity's sake, let's see here. 39 was 495. Nope. I'm not going to do that to you, so don't worry. Okay? We good on that? Yes, ma'am.
Will there be questions like that on the quiz, like find the coefficient of x to the...
I don't think so, but it works basically, it's just the same way. It's saying, okay, I know what power I want. You just figure out what goes where in your setup. Okay? But we're going to practice, okay? So here, let's do some more problems. We started this last class. I can figure out where I put the problems. Here we are. Let's go to these problems. And I'm just going to write them separately because I think that's too small. So I want you to simplify x minus 3 factorial x factorial over x minus 2 factorial x plus 1 factorial. And I want you to use sigma notation to do 3 plus 5 plus 7 plus up to 49. With these first two here. Any questions on those two? Yes, sir. No, we need to get through these. Fudge. Because I have to give you guys 30 minutes for the quiz. So 21, so you only have 7 more minutes, so I don't want to. Just guys, calm down, please. So I need to hit pause. Okay, breathe. Just take a second. Let me give everybody a chance to look at this. Just calm down. I might have made a mistake. I want to wait and see what you guys have to say. Yes. No, that's if I asked you for the coefficient of x to the 7th. It's okay. That's why I'm trying to give you guys practice for this. When they ask for the term, the guy that goes out in front is the power over the term minus 1, which is where 12 over 6 came from. If they ask you for the coefficient, then you know that's the power that goes above the x. Allie? You didn't get this? Okay, did I hit it? I might have typed it in wrong. 924. Yeah, I did 72 instead of 729. Okay. Times 729 times 64. I just hit the wrong button on my calculator. It's okay. Or I left off a button. So that is 43110,144. Is that better?